Hello dear students, welcome back to Rauser's class. In the previous video we discussed about many points, so I'm just giving the headlines of the previous topics which we have discussed so far. So in case if you have not revised these videos, just go through the playlist. First we studied about gas laws. I have explained all the gas laws: Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law. These all things we have discussed. Then we have also studied about ideal gas equation, then as well as combined gas equation. Then we have studied some IIT questions, JEE questions based on the topic. Then we have finished about Graham's law of diffusion, also Graham's law of diffusion, as well as some NEET questions based on that also we have discussed so far, right? So in case if you have not watched these videos, kindly go through the playlist where you will find all these videos. Now today's topic. So today we are going to study about Dalton's law of partial pressure. Dalton's law of partial pressure. Yes, this is a very simple topic. It is a very easy topic rather. So but topic is little tricky here. To know the meaning, first of all we should know the meaning of partial pressure. What is the meaning of partial pressure? So to know that partial pressure meaning, first of all there are two words. One is vapor pressure. There are two words in this topic. One is vapor pressure, the other word is partial pressure. What is the meaning of vapor pressure and partial pressure? Let us see. Vapor pressure means, suppose you take a container, closed container. In this closed container, let us say there are the gas molecules of say A gas or X gas. These are X gas molecules, and now here we connect it to the barometer to measure the pressure. So here the pressure something, this is the initial mercury level, this is the final mercury level, and this is called as the pressure, and that pressure is called as vapor pressure. Correct? So we understood vapor pressure. Definition also I will give you, don't worry. So first example I have explained. Now partial pressure. What is the meaning of partial pressure? In one container, there are some A gas molecules. There are some A gas molecules as well as B gas molecules. These are some B gas molecules. Now here the pressure will be developed in the container. In this barometer some pressure will be generated. Here pressure will be generated due to A molecules as well as B molecules. That is called as partial pressure of A and partial pressure of B. So here it is a partial pressure word, and here we use the word partial vapor pressure, which symbol is P naught. Now did you get the point? What is the difference between these two, vapor pressure and partial pressure? Here only one gas is there, and the pressure exerted by only one gas is called as vapor pressure. And partial pressure means there are two or more gases, and the pressure exerted by each gas is called as partial pressure. Let's write the definition. Here vapor pressure, it is the pressure exerted by a gas in a closed container. That is called as vapor pressure. Now partial pressure, how can you define? It is the pressure exerted by any one gas over the mixture of gases gases, and that is called as partial pressure. And here the vapor pressure symbol, its symbol is P naught, whether you can say X gas or Y gas or something, P naught. And here the symbol is, you can say partial pressure of A symbol is PA, or partial pressure of B symbol is PB. So this is the difference between vapor pressure and partial pressure. Understood? Here only one gas is present, and the pressure created by that one gas is called as vapor pressure, and here two or more gases are there, and the pressure created by each gas is called as partial pressure. Now partial pressure and vapor pressure, whether you talk about both, these two depends on two factors. Whether you talk about partial pressure or vapor pressure depends on two factors. Yes, what are the factors that affect partial pressure and vapor pressure? One is, of course, strength of intermolecular force. The first point is strength of intermolecular force, which is, yes, what do you think, directly proportional or inversely proportional? You just think, suppose if the intermolecular force is weak, then gas molecules can move very freely and will create high pressure on the walls. If the intermolecular force is less, or if the intermolecular force is more, then gas molecules cannot move freely, the pressure will be less. Which means if the intermolecular force and vapor pressure both are inversely proportional, vapor pressure, this is the relation between intermolecular force and vapor pressure. Now example, this is a one time NEET question. I don't remember the year, maybe 2017 or 18. They have given two things, H2O, ethanol, and I think ether also, ethanol and ether, diethyl or dimethyl ether. Here what is the correct order of vapor pressure? That was the question asked. What is the correct order of vapor pressure? What can we see here? Strength of intermolecular force. Do you know what is the intermolecular force in water? The intermolecular force is strong hydrogen bond. Strong hydrogen bond. I hope you know the hydrogen bond concept. So if you don't know the hydrogen bond concept, you message me in the comment box. I will make the next video based on hydrogen bond. Okay, and here in ethanol, yes, it is a hydrogen bond, but that is little bit weak hydrogen bond. And here the force present in ethanol, diethyl ether, is dipole force. So dipole force is weakest force among these. It is a weakest force. Then it is a little strong force, ethanol, sorry, H bond, and this is very strong force. So now can you tell me the vapor pressure order? The question is asked, that one only. What is the vapor pressure order? Yes, the compound in which intermolecular force is weak, their vapor pressure will be more. So this is the weakest force. So intermolecular force is weak, so vapor pressure will be more. So here answer will be dimethyl ether having very high vapor pressure than ethanol than water. So got it? This was a question asked in NEET, but not exactly like this. Somewhere it is related like this. So here I repeat once again, factor number one, that is the strength of intermolecular force. If intermolecular force is weak, if the intermolecular force is weak, so the molecules can move very freely and will create high pressure. So if intermolecular force is weak, the pressure will be high. If intermolecular force is strong, the pressure will be weak. So very simple, inversely proportional. The question is given water, ethanol and dimethyl ether, arrange them according to the vapor pressure order. So this is what the answer is. Got it? Now I'm going to the second factor. The second factor is temperature. Now think about it, how temperature is related with pressure. Suppose I have two cases. One is H2 gas at 30 Celsius and second one is H2 gas at 60 Celsius. In which case pressure would be more. Think about it. So if the temperature is more, the collisions will be more. If collisions are more, the pressure will be more, which means temperature is directly proportional to vapor pressure. So here uh, this water at 60 Celsius has a high vapor pressure and this one has a low vapor pressure. So you can give symbol like this. These are the two factors which discuss about vapor pressure. So clear about it. So we finished about vapor pressure and partial pressure, two concepts. I hope you understood it. If you understood, then put a hit on the thumbs up or like button and share some comments or feedback. Yes, your feedback will motivate me to work more and more. Yes, and it will help me to improve or deliver the best lecture also. Now coming to the regular topic. So now we discussed about vapor pressure topic. Now I'm going to study about explain you Dalton's law. What is Dalton's law? Many people teach Dalton's law, but they miss about very simple fundamental. Let us see that one. So here I'll explain you with example, then definition. Suppose you have a one gas, let us say gas A, in container gas A, and the pressure of gas A is, let us say, 6 atm. And now the same vessel, same type of vessel, condition is very simple thing. Yes, the vessel is same, so constant volume, keep that in mind. These conditions matters a lot. And here I'm putting gas B, and let us say the pressure due to gas B is 4 atm. The pressure due to gas B is 4 atm. Now I am taking this container of same volume. In all these case, volume is common. Now I am putting A gas and B gas. Here both gases are kept. Here A gas and B gas. Now what is the total pressure? The total pressure is sum of the partial pressure, that is PA plus PB, which is equal to 10 atmosphere. That is Dalton's law. Now here conditions. What are the conditions that we understood? Conditions for Dalton's law. Without these conditions, Dalton's law is not valid. Conditions is volume is constant. Volume is constant. Here the vessel, here it is of volume V, it is also volume V and it is also volume V. And condition number 2, that is non-reacting gases. The gases should be non-reacting. If the gases are reacting, then the rule is not followed. I'll give you one example. So let me say example 1, like NH3 one gas and HCl another gas. In this case, Dalton's law is not applicable because NH3 and HCl react to give NH4Cl, ammonium chloride. So that's why if the mixture is, if this is ammonia gas, if this is HCl gas, then Dalton's law is not applicable. Second example, H2 and O2 gases, then Dalton's law is applicable or not? Yes, it is applicable. You may ask me, sir, why? H2 plus O2 gives H2, that we are not knowing. So, but the reaction does not occur at room temperature. Does not occur at room temperature. So at room temperature they do not react with each other. That's why here I can apply Dalton's law. Now another example, SO2 and O2. Yes, SO2 and O2, do react to QSO3, but at high temperature, so at room temperature they do not react. That's why here Dalton's law is applicable. So understood, the conditions for Dalton's law is the volume of the container in three case should be constant and non-reacting gases, and condition number 3, that is temperature is constant. Temperature is constant. When these conditions are valid, then only Dalton's law will be followed. Otherwise, what people teach in Dalton's law is the total pressure is equal to sum of the partial pressure. That is what the Dalton's law they teach. Yes, even you must have studied in your class 11th or in your books also, but this condition is correct when these conditions are followed. Now statement, what is the Dalton's law statement? At constant pressure, you have to mention at constant, so not pressure, at constant volume and at constant temperature, at constant temperature, the total pressure exerted by mixture of non-reacting gases, is equal to the sum of their partial pressure. This is the final statement of Dalton's law. Here all the conditions are mentioned. So if you write this one, then it is always correct all over India or all over the world. So conditions are constant volume at constant temperature, mixture of non-reacting gases, then the total pressure is equal to sum of the partial pressure. So I can say the statement total pressure, suppose it is a P total, is equal to sum of the partial pressure, that is a PA plus PB plus PC plus so on. This is Dalton's law statement. Now based on this we can do some derivation. Now derivation is, see, we have a gas A in container at volume V and temperature T, and we have gas B at volume V and temperature T. Now we have same gas A comma B, both gases at constant volume at temperature T. Now here, as per ideal gas equation, what is the formula for ideal gas equation? PA into V. PV is equal to nRT. I am applying Dalton's law, ideal gas equation. PV is equal to nRT. P means pressure of A is equal into V is equal to N. N means number of moles of A. So Na into RT. Understood? In this case, I am applying Dalton's law. So ideal gas equation. And here also let us apply ideal gas equation. So PB, partial pressure of B into V, is equal to number of moles of B into R into T. PV is equal to nRT. And here also we will apply total pressure P is equal to PA as per Dalton's law, PA plus PB. Now P is equal to, here from this what can we write? PA is equal to NA into RT over V. Can we write like this? Here PA we got. Now from here PB is equal to, what can we write? NB into RT over V. And now put this PA and PB here. So is equal to NA into RT over V plus NB into RT over V, and P is equal to NA plus NB common, here RT by V is taken out. Now here we are giving equation number. This is equation number 1, this is equation number 2, and this is equation number 3. Now let us divide 1 and 3. Equation 1 divided by equation 3 implies what you will get. PA is equal to NA into RT by V, and P here NA plus NB into RT by V. So here RT by V get cancelled. Here what is left? PA over P is equal to NA over NA plus NB, which is equal to number of moles of A upon total number of moles, which is mole fraction of A. That is mole fraction of A. So implies PA is equal to P into mole fraction of A. This is the final statement. It means partial pressure of any gas is equal to, this is the partial pressure. It's the partial pressure of any gas is equal to total pressure into mole fraction of that compound. So similarly you can also make for PB. Similarly you can say PB is equal to P into mole fraction of B. So this is the Dalton's law final statement. So if some people say like this, sir, I'm a B group student, what I should remember? So this is only what you have to remember. Partial pressure of any compound is equal to total pressure into mole fraction of that compound. Now sharing with you very important point, about Dalton's law. Generally many people ignore this point, but I'm explaining you. So to understand that point, you take a container. It is a empty vessel. This is empty vessel, and in this empty vessel, suppose you took oxygen gas. Okay, so now there will be some pressure, and that is called as pressure of oxygen gas, pressure of O2 gas. Let us say the pressure of O2 gas is 10 atm. But now let us take another container, and in that container, suppose there is a small amount of water also, saturated solution. We say that this is water, and now in this container we take O2 gas. So here this is a water is present in the container. Understand? Now in this case the pressure of O2 gas, let us say the pressure of O2 gas won't be 10 atm, that is 10.5 atm. Here the pressure of O2 gas, this is called moist O2 gas, because it is moistured with water. So this is a moistured O2 gas. So here the pressure of moist gas is equal to pressure of dry gas plus pressure of water, because here the extra 0.5 pressure, because some water is also forming water vapor, small water vapor is created, so that also create pressure. So therefore pressure of moist gas, if I want pressure of dry gas in numerical, is equal to pressure of moist gas minus pressure of water. The pressure of water is also known as aqueous tension. So pressure of dry gas is equal to pressure of moist gas minus the pressure created due to water is also known as aqueous tension. So we have to see the question carefully, whether they are talking about empty vessel or they're talking about the vessel which is saturated with water. So keeping those two things in mind, we can decide. Suppose if water is there, the pressure created over there is called as moistured pressure. If empty vessel is there, that's the pressure of dry gas. That is pressure of dry gas. So but what if water is present, then the pressure created is called as moistured pressure. So the pressure of moist gas, which is equal to pressure of dry gas plus pressure of water. So the pressure of, if we want the pressure of dry gas is equal to pressure of moist gas minus pressure of water, and the pressure created due to water is called as aqueous tension. Now to understand this, I'll explain you some numericals so you will understand it more clear. Right. This is the question with me. You see, a sample of air contains N2, O2 and H2O. You see, they said H2O, which means you are talking about water, so which means saturated solution. It is saturated with water vapor and the total pressure is 600 torr, and the vapor pressure, the pressure due to water, is 40 torr, and the molar ratio of N2O2 is 3:1. The partial pressure of N2, what we have to find is partial pressure of N2 in the sample. Yes, let us write the given data first. The total pressure P total is equal to how much it is given, 640 torr, and the pressure of water, so pressure of water is equal to 40 torr, and the molar ratio, it means number of moles of N2 is to number of moles of O2, which is equal to 3:1. And what we have to find, the partial pressure of N2 is equal to question mark. So you have to write the given data, then you can understand. Yes, now how can we write? We know that the partial pressure of, total pressure of any gas is equal to pressure of N2 plus pressure of O2 plus pressure of H2O, because now water is there, that's why pressure of H2O will come. So the total pressure is, now it is a moist pressure, so which is a 640 is equal to PN2 plus PO2 plus 40. So which means PN2 plus PO2, which is equal to 600 torr. That is equation number 1. It is a P total. Now here from this we can get the mole fraction of N2. Mole fraction of N2 is equal to number of moles of N2 over number of moles of N2 plus number of moles of O2. What is the number of moles of N2? It is a 3 over 3 plus 1, that is equal to 3 over 4. Similarly, mole fraction of O2 is equal to number of moles of O2 over number of moles of N2 plus number of moles of O2, which is equal to 1 over 3 plus 1, which is equal to 1 over 4. Now what, according to Dlatons law, the partial pressure of any gas is equal to P total into mole fraction of that N2 gas. But this P total is of dry. Then only you will get the partial pressure of dry N2 gas. So what is the P total of dry N2? Total, it is a 600. So is equal to 600 into mole fraction of N2 is 3/4. So which is 150 into 3, which means 450 torr. So the answer is 450 torr. Is it there? Yes, this is the answer. Understood this question? So here this is a P total. The total pressure is moistured one, so that is a PN2 PO2 and PH2O. Here PH2O is subtracted and we get the total dry pressure. Understood this one? So I hope you are understanding my class. These are very important questions. Now next question, one more question of the same type. You see, a dry gas occupies 136.5 centimeter cube at STP. If the same mass of the gas is collected over water at 27 Celsius, the pressure is 725. The 725 is pressure over water. What volume does it occupy? So here the initial volume P1 we will write V1 is equal to 136.5 centimeter cube. Now the pressure it is said STP. So STP pressure you know, which is a 1 atm, and the question is in torr, so we will write 1 atm is equal to 760 torr. Now when it is collected over water, that is a 725 pressure. It means the pressure of gas plus the pressure of water, because it is collected over water, which is equal to 725 torr. Now the pressure of water is given separately, 25 torr. So the pressure of gas is equal to 725 minus pressure of water, which is equal to 725 minus 25, which is equal to 700 torr. This is P2, rather I can say. Now V2 is equal to question mark. So it is a Boyle's law question. We can write P1 V1 is equal to P2 V2. P1 is 760 into V1 is 136.5, which is equal to P2 is a 700 into V2 is question mark. So from this you can easily find out what is V2, and you give me the answer and mention it in comment box, right? So these are the questions based on aqueous tension.
Subscribe now and press the bell icon. Never miss an update. Subscribe now and press the bell icon.